All right, this is a video for geometry on the surface area of prisms and cylinders. We'll start with a few definitions, a couple formulas maybe, and then move on to some solved examples. So first off, we'll informally define some of these terms. First off being a prism. A prism is a solid object that has polygons as its faces. So in other words, a cylinder or a sphere is not a prism, so its faces need to be polygons. And then most importantly, it's what we call its bases are parallel and congruent. Okay, so there's an example of a prism right there with those two bases. And then the sides of the prism, the faces that are not the parallel congruent sides are called the lateral faces. So once again here you can see the bases in this triangular prism are parallel and congruent. And then additionally down here you can see that a prism doesn't have to have the bases sort of directly on top of each other. We can have what's called an oblique prism where the top face is kind of skewed over, shifted over a little bit relative to the bottom face, but still those two faces need to be parallel and congruent. All right. In this video, we're going to be looking at the surface area of these shapes, and really what you need to think about is just finding the area of the individual faces of these prisms. So let's go over some of these again. Lateral face, as I mentioned, are the, and what we're seeing here is the vertical faces, the faces that are not parallel to each other. The base refers to sort of the top and the bottom of the prism, but of course the prism could be lying on its side, and we would still call the same faces the bases. The altitude or the height is just the perpendicular distance between the two bases. A right prism is a prism where the lateral faces are perpendicular to the bases of the prism, and then an oblique prism is a non-right prism. Okay. So hopefully those terms make sense. Let's just do a little bit of practice, and I think it'll all become crystal clear. So first we're going to find the surface area of this right prism. It looks like it's a rectangular prism because the bases are rectangles. There are some teachers, some books that ask you to memorize a formula for these guys. I don't. I just ask you to stay organized and keep track of what you're trying to find. So I like to find the top and the bottom first. Well, not first, but I like to label that I'm finding them. Then I like to label that I'm finding the left and the right, and then the front and the back. And then we're going to add up all these areas. So hope you can see the top and the bottom. We're going to have two of those faces, and the area of each face is 19 times 6.5. So the area of the top and the bottom together is 247 square centimeters. Left, right, we're going to have two of those total, and those are these faces here, and those are going to be, let's see, 2 times 6.5 times 29. And so that gives us a total of 377 square centimeters. And then the front and the back are, I think, clear, this large front face, and then the back face behind it. We're going to have two of those, and those are going to be 19 times 29. So that gives us 1102. And then we're just going to add those three areas together. 247 plus 377 plus 1102. That gives us a grand total of 1,726 square centimeters. So the surface area, again, is just the area on the outside of this prism, as if you were going to paint the prism. How much paint would you need? And in this case, we need to cover a total of 1,726 square centimeters of area. Okay. Most important tip is to just stay organized. Okay. You don't need to memorize a formula or anything for these guys. Just stay organized. Let's do a little bit of a harder one, finding the surface area of this triangular prism. So the two bases are right triangles. And then we have three lateral faces that are rectangles. So again, let's do top and bottom. Let's do the front. We can do the back left and the back right. So again, my big hint, just stay organized. So top and bottom, we have two triangles, and that each triangle has an area which is a half times the base times the height. Okay? And that gives us a grand total of 12 square centimeters. The front, we only have one front, but we don't quite know the base of it yet until we realize we could use the Pythagorean Theorem and realize that this is a 3, 4, 5 triangle. So the front is a rectangle, that's 5 by 6, which is 30 square centimeters. The back left is 3 by 6, which is 18 square centimeters, and the back right is 4 by 6, which is 24 square centimeters. Let's add those all up. And I get a grand total of 84 square centimeters. So needed to use the Pythagorean Theorem there, but more importantly, you need to keep track of your pieces that you're calculating. If we imagine a prism as having not a pentagonal base, but a circular base, or not a polygonal base, not a polygon base, but a circular base, sort of a regular polygon with an infinite number of sides, we can apply some of this same information to a cylinder. Okay, so a cylinder you can think of as a circular prism. And I want you to imagine kind of cutting apart a soda can, and we have a disc up top, a disc down below, and then unfolding the sides, we get a rectangle. Okay, so the formula for the surface area of a cylinder is 2 pi r squared, so that's the two discs at the top and the bottom, plus 2 pi r h. And where does this 2 pi r h come from? The 2 pi r is the base of this rectangle, and h is the height of the rectangle. Okay, so 2 pi r h gives us the lateral area of this cylinder. Okay, so that's the surface area of a cylinder right there. Let's do an example. We have a diameter of 5, a height of 12, so sometimes it's nice to maybe sketch a quick sketch of this 12, and then I'm going to throw in a radius of 2.5, half of that diameter. So our surface area is going to be 2 pi times 2.5 squared. That's going to give us the top and the bottom areas, plus 2 pi times 2.5 times 12. I want to try to keep all this in terms of pi, so I'm not going to type in 3.14 or anything, but I'm going to simplify as best as I can right now. So this turns into 12.5 pi plus 60 pi, and I get a 72.5 pi square centimeters total. So that's the total surface area of that cylinder. Bit of a real world problem as our last problem, and you can see we have a paint roller right here with a length of 6 inches and a diameter of 2.5 inches. It looks like it's putting down some sort of a design right here, but what we're going to try to do is just imagine that the design was covered in paint as well. How much area can one roll of the paint roller cover? Okay, so we're not looking for the area of the discs on either sides of the cylinder. We're just looking for the lateral area of the cylinder. So that's going to be 2 pi r h. Okay, and so that's going to be 2 times pi times the radius is 1.25 inches times h, which is 6 inches. Okay, and let's simplify that down. And I'm going to use pi as a decimal approximation in this case and get approximately 47.12 square inches. And that would be the total area that one rotation of this paint roller could apply in terms of how much paint it could apply on the surface. All right, surface area of prisms and cylinders. We got through it. That's a good place to stop.